So this is problem 250, or problems 250 and 251 that we're doing in class. For the first part of it, these are both using the same figure. They want us to express f1, f2, and f3 as Cartesian vectors. So let's just go ahead and do that. And that'll actually help us with the second one, or the second part. So f1, that one is, the magnitude is 15 kilonewtons. And that angle is 40 degrees. So for the I component of it, the I is actually along this x-axis. So it's this one here. We bring that down. And so that angle is 40 degrees, so it would also be, so I'll do it in red, it would be, it's this, that component of that F1, or we could bring it up here. And so that's going to equal 15 kilonewtons times the sine, because the sine is opposite, sine of 40 degrees. Just like anything, you could do it slightly different. And that's in the I direction, and that's positive, because it's in the positive x. And then for the y, it's also positive, 15 kilonewtons. And so for the y, we're actually interested in this one here. And so that would be cosine of 40 degrees, because that would give it the adjacent. And that's in the j direction. Sorry for the change in the ink color. So I'm going to grab my calculator and go ahead and calculate that out. So that gives us 9.64 I plus 11.49 J, and that's in kilonewtons. All right, now for F2. So F2, and this one we know it's a common triangle, so the 5, 12, 13. And so with F2, the magnitude is the 26 kilonewtons, and we're just going to multiply that by, for the I direction, we're going to have 12, because it's the horizontal, over 13, so it's 12 over 13 I, and that's in the negative x direction, so that'll be a negative. And then for the y, it's actually positive, and that's just that 5 over 13. 5 over 13 J. It looks like I just wrote down something wrong, so it was 12 over 13, which is what I said, but apparently I didn't write it. So if we multiply that out, I'll find my calculator. So it's basically negative 24 I plus 10 J, and that's in kilonewtons. And now for F3, I'm going to try to squeeze it onto this page. Yeah, I can zoom down a little bit. But for F3, so we know the magnitude is 36 kilonewtons, and then we know that angle is 30. So F3 is going to be that 36 kilonewtons, and multiply that by, so we want the x component for the I direction, so that's in the positive x, and it's going to be that cosine of 30 degrees I, so it's SOHCAHTOA, cosine is the adjacent one, and then minus, because it's in the negative y direction, minus sine of 30 degrees J. And so now we're just going to multiply that 36 kilonewtons through there. So we get 31.18 I minus 18 J, and that's in kilonewtons. Makes it shut parentheses. I'm going to go ahead and circle them just in a different color. So we have this one is F2, we have F1, and then we have F3. And these are going to be helpful for us as we go to the second part. So for the second part, they want us to do the resultant force and direction counterclockwise from the positive x-axis. So what we just found is going to be helpful for that. So I'm going to go on to the next page. So the resultant force is going to equal F1 plus F2 plus F3. We just found out what those F1, F2, and F3 is. So for F1, I'm going to go back and grab it, it's that 9.64I plus 11.49J. That's in kilonewtons. And then plus F2, which is going to be that negative 24I plus, I just forgot, 10J. So this is F2 plus F3, which was that 31.18I minus 18J. That's also kilonewtons, so that was the F3. So for the resultant force, we just want to add those all together. So let's just add, first we'll add all the I components. So these are these here. So 9.64, negative 24, and then 31.18. So we get 16.82I. And then let's add the J components. So 11.49, 10, and then subtract 18. So we get plus 3.49J, and that's in kilonewtons. So now we know what that F sub R is. They want us to find the magnitude of it. So the magnitude of FR, which would also equal just FR without the hat on it, that would be the square root of 16.82 squared plus 3.49 squared. And that's kilonewtons. And so that's going to give us 17.18 kilonewtons is our FR, or the magnitude. And then it also wants us to know, or it wants to know the direction counterclockwise from the positive x-axis. So that FR, let's see, let me just draw it really quickly. So the FR is 16.82 along I, so that's 16.82, and then it's just 3.49 in the J. So that's that FR. So we just want to know this angle, and that'd be counterclockwise from the positive x-axis. This is x. So we want to know what that angle is. So we could do, let's see, tangent of theta is going to equal the opposite. So that'd be that 3.49 kilonewtons over that 16.82 kilonewtons. So that would give us theta equals, let's see, theta equals 11.7 degrees. So now we've got everything. So that theta is going to equal 11.7 degrees counterclockwise from the positive x-axis. So there we go.